so the next question, let's go back up. So the next question is actually a very big question. So I'm actually not going to write the entire thing. I'm just going to go back and copy it so that it makes it easier for me. So I don't have to scroll up and down. Okay, so this next question is basically fractions, algebraic fractions, and we have to simplify these algebraic fractions. Now, the first thing that you should think of whenever you're dealing with such a question is that you need to try and look at places where you can simplify, right? And this is 2.2.2. Okay, so it's 2.2.2, so 2.2.2. So you're looking for places where you can factorize. So you first look at each numerator and each denominator. And if you can factorize it, first factorize before doing anything else. Okay, so the first one that I can see here at the top, it's x to the power 3 plus x to the power 3. Actually, that you can factorize. This is cubic factorization, where you'd have just x plus y, right? Because you'd basically in the first bracket ignore to the power 3 and just write it as x and y, right? And then inside, then it's x squared, and then it's the opposite of what we have in the first bracket, and then it is the multiplication of the two terms, and then at the very end, it's the square of the last term. So then it's just y squared, right? So we have that right at the top. And then here now we have 2x to the power 3 minus x squared y minus 3y squared. Now the first thing, right? What type of factorization can you use here? It's not so clear unless you can see that there is a common factor between all of them. And the first thing we'll do is take out the common factor. So that's just x. So then it's 2x to the power 3, right? Oh, to the power 2, sorry. To the power 2 minus xy minus 3y squared. Okay, so that's quite clear. So that's quite clear. That's the first one there. Okay, let me minimize it. Move it up a bit. Right there. Okay. And then that is being divided by x to the power 3, y minus x squared, y squared plus y, xy to the power 3, all divided by 4x to the power 4 minus 9x squared, y squared. Okay, so what do we do now? Okay, so the first one at the top here, what can we do? I can see a common factor for all three of them, for all three terms. The first one, the second one, and the third one. So let's first do that. Let's first take that out. So let's take that out. And so what would that be? That would be x, y to the power 1, yeah, 1, yes, 1. So it's xy, and then we'll have x squared, right? Minus xy plus just y to the power 2, right? And that would be our factorization there. And now underneath as well, is there a common factor? Yes, there is. And that is x to the power 2. So let's write that, x to the power 2, x to the power 2, right? And that would be 4x squared minus 9y squared. Okay. And then we are done with the first step. The first factorization that we've done, we are done with it. Okay. However, now the problem is, as you can see, there's not much you can do because you can still see some places where you can factorize continuously, right? In the first place up there, if we look at x squared minus xy plus y squared, is that factorizable still? Yes or no? Can it be factorized? In this case, it cannot, right? It cannot be factorized. So that is at its simplest form, so we don't do anything else. Okay, we look at the bottom one in the denominator. So we have 2x squared minus xy minus 3y squared. Now, in this case, it can be factorized. So let's first write out first the numerator first as is. So numerator as is. All right, all over. Okay, now we already taken out x, so that's just x. But now we are factorizing this, and this is going to be a quadratic, so we know that it's 2 brackets. Now we know firstly that we're going to have x, right? We're going to have x and x there, but we're also going to have y and y there to give us y squared. Okay, now this is where things get a bit complicated, right? So now we first ask ourselves, what are the two numbers that we can multiply together to give us 3? And that's 1 times 3, right? So one of them is just going to be y, and one of them is going to be 3y, right? So let's just say this one's 3y, for instance. Or let's say this one's 3y. Let me say this one's 3y. And then that's y there. Okay. Now, for it to be negative 3y, one of them has to be negative and the other one has to be negative as well. Right, positive, right? So let's make this one positive, and let's make this one negative. And then because this will multiply with 2, this would be 2x positive 2xy. That would be added with negative 3xy. That would give us negative xy. So this would be its factorization there. Okay, and then we divide it. Now, again, we look into the bracket. If there's still something that we can factorize, can we still factorize this? No, this still stays x squared minus xy plus y squared. Okay, so this still stays the same. Okay, and then underneath, you can see we have a difference of 2 squares. So it's actually x squared, and this would be 2x minus 3y, and this would be 2x plus 3y. Okay. And so now we factorize completely. There's no more factorizations that we needed to do. We needed to factorize twice. However, there's no more factorizations that we need to apply to simplify it. So now we can start working with the fractions themselves, right? Remember, when you're dividing fractions, it means that the one that is dividing needs to swap. The denominator will become the numerator. This would become the numerator, and the numerator will become the denominator. And division will become multiplication. Right. So I'm actually going to copy this here to make it easier. So copy and paste right there. Because there's nothing that we're going to do to this part, right? But in this case, this is the only thing we need to do. We needed just to swap, right? And we changed the division to multiplication as whenever we do fractions. So now at the top, we have x squared, 2x minus 3y. Here we have 2x plus 3y. And that is all divided by xy, x squared minus xy plus y squared. Now, when you get to this point, the first thing you need to be asking yourself is what can cancel each other out, right? And in this case, what can cancel each other out? We can see that here, x squared minus xy plus y squared is the same as x squared minus xy plus y squared. And remember, when we're canceling each other out, it has to be something at the top canceling something at the bottom. Not that something at the bottom is the same as the bottom, then you can cancel it out. Or at the top and the top, then you cancel it out. No, it has to be something at the top canceling something down at the bottom, right? So that's how that works. Okay, so we cancel out these two, right? Because they are the same. So they're canceled. And then we look for more things that we can cancel out. So I can see here 2x minus 3. I can cancel it out like that, right? I can cancel it out with that one there. Okay, is there anything else? Yes, x plus y and x plus y. Yes, this can cancel out with him. Yes, And what else? Here, we actually have x squared.